Hello, welcome to how to solve this very nice radical equation. X squared minus 1 is equal to square root of x plus 1, and we need to find all possible values of x. Since this expression x plus 1 is under radical sign, so this must be greater than or equal to 0. This expression x plus 1 must be greater than or equal to 0. If we move this plus 1 to the right side, then x must be greater than or equal to negative 1. And because the right side of this equation must be greater than or equal to 0, so left side of this equation, this expression x squared minus 1 must be greater than or equal to 0. This expression x squared minus 1 must be greater than or equal to 0. And if we move this negative 1 to the right side, then x squared must be greater than or equal to 1. So we have two conditions for the checking of solutions of this equation. The first one is x must be greater than or equal to negative 1, and the second one is x squared must be greater than or equal to 1. Now let's start by squaring both sides of this equation. X squared minus 1 whole squared is equal to square root of x plus 1 squared. Now according to this algebraic identity, a minus b whole squared is equal to a squared minus 2ab plus b squared. This x squared minus 1 whole squared is equal to x to the power 4 minus 2x squared plus 1 is equal to, this square will be cancelled with this square root, and at the right side left x plus 1. Now we move this x plus 1 to the left side. X to the power 4 minus 2x squared plus 1. This plus x becomes negative x at the left side, and this plus 1 becomes negative 1 at the left side, is equal to 0. Now this plus 1 will be cancelled with this minus 1, and here left x to the power 4 minus 2x squared minus x is equal to 0. Now from here we can factor out x. So we factor out x times, in bracket left, x cubed minus 2x minus 1 is equal to 0. Now from here either this expression x is equal to 0, or this expression x cubed minus 2x minus 1 is equal to 0. From here this is the first value of x, and to find other three values of x we solve this cubic equation. Now because in this expression we have no term with second power of x, so we add and subtract x squared in this x cubed, like this. X cubed, we add x squared and we subtract x squared, and we split this negative 2x as, we split this negative 2x as negative x minus x. We split this negative 2x as negative x minus x, and in the last this negative 1 is equal to 0. Now from these two terms x cubed plus x squared, we can factor out x squared. X squared as a common factor, and in bracket left x plus 1. And from these two terms, negative x squared minus x, we can factor out negative x as a common factor, and in bracket left x plus 1. And from these two terms, negative x minus 1, we can factor out negative 1 as a common factor, and in bracket left x plus 1 is equal to 0. Now as you can see, this expression x plus 1 is a common factor. So we factor out this x plus 1 as a common factor, and in bracket left this x squared, this negative x, and this negative 1. In bracket left x squared minus x minus 1 is equal to 0. Now from here, either this expression x plus 1 is equal to 0, or this expression x squared minus x minus 1 is equal to 0. From here, x is equal to negative 1. This is the second value of x. And to find other two values, we solve this quadratic equation. This is not factorable, so we solve it by quadratic formula. In this equation, a is equal to 1, and b is equal to negative 1, and c is equal to negative 1. And according to quadratic formula, x is equal to minus value of b minus 1 plus or minus square root of value of b negative 1 squared minus 4 times value of a 1 times value of c negative 1 divided by 2 times the value of a 1, and x is equal to minus minus plus 1 plus or minus square root of negative 1 squared is 1, negative 4 times 1 times negative 1 plus 4 divided by 2 times 1, 2, and x is equal to 1 plus or minus square root of 1 plus 4, 5 divided by 2. So from here we get two values of x. x3 is equal to 1 plus square root of 5 over 2, and x4 is equal to 1 minus square root of 5 over 2, and value of x2 is equal to negative 1, and value of x1 is equal to value of x1 is 0. Value of x1 is 0. So we have 4 values of x. Now let's verify these values of x to check for the solutions of this equation. To verify these values of x, we use two conditions. The first condition is x must be greater than or equal to negative 1, and the second condition is x squared must be greater than or equal to 1. We use these conditions. Condition 1 is x must be greater than or equal to negative 1, and condition 2 is x squared must be greater than or equal to 1. We use these two inequalities to check the solutions of this equation. First we check this value of x1, 0. Value of x1, that is 0. We put in this condition the value of x is 0. 0 is greater than or equal to negative 1. 0 is greater than negative 1, so this condition is true. Now we put this value of x1, 0 in this second inequality. 0 squared greater than or equal to 1. 0 squared is 0 is greater than or equal to 1. 0 is not greater than 1, so this condition is false. So we reject this solution. Now we check the second value of x, negative 1. We check the second value of x, that is negative 1. First, in this inequality we put the value of x negative 1. Value of x negative 1 is greater than or equal to negative 1. And it is true that negative 1 is equal to negative 1. So this condition is true. Now we put this value of x to negative 1 in this second inequality. Negative 1 squared is greater than or equal to 1. Negative 1 squared is 1 is greater than or equal to 1. It is true that 1 is equal to 1. So this second condition is also true. And because both conditions are true, so this value of x to negative 1 is a valid solution. Now we check this third value of x, 1 plus square root of 5 over 2. Value of x3 is 1 plus square root of 5 over 2. And we put this value in this inequality, must be greater than or equal to negative 1. It is obvious that 1 plus square root of 5 over 2 is greater than negative 1. So this condition is true. Now we put this value in this second inequality, x squared must be greater than or equal to 1. The value of x is 1 plus square root of 5 over 2 squared must be greater than or equal to 1. Now this square root of 5, this square root of 5 is approximately equal to 2. So we replace this square root of 5 with 2. 1 plus square root of 5 is approximately 2 over 2 whole squared must be greater than or equal to 1. And 1 plus 2, 3 over 2 squared is greater than or equal to 1. 3 squared is 9 over 2 squared is 4 is greater than or equal to 1. Now this 9 over 4 is approximately equal to 2. So we replace this 9 over 4 with 2 is greater than or equal to 1. So 2 is greater than 1, so this condition is also true. And because both conditions are true, so this solution, value of x3, 1 plus square root of 5 over 2, is also a valid solution. This is verified. Now let's verify the fourth value of x, 1 minus square root of 5 over 2. Now we verify this fourth value of x, 1 minus square root of 5 over 2. First, in this condition we put the value of x4, 1 minus square root of 5 over 2 must be greater than or equal to negative 1. And this square root of 5, this square root of 5 is approximately equal to 2. So we replace this square root of 5 with 2. Like this, 1 minus square root of 5 is 2 over 2 is greater than or equal to negative 1. And 1 minus 2 is negative 1 over 2 is greater than or equal to negative 1. Now it is true that negative 1 over 2 is greater than negative 1. So this condition is true. Now we put this value of x4, 1 minus square root of 5 over 2 in this second inequality. Value of x4 is 1 minus square root of 5 over 2 whole squared is greater than or equal to 1. and because the square root of 5 is approximately equal to 2, we replace this square root of 5 with 2. 1 minus square root of 5 is 2 over 2 whole squared is greater than or equal to 1. Now 1 minus 2 is negative 1 over 2 whole squared is greater than or equal to 1. And negative 1 over 2 whole squared is 1 over 4 is greater than or equal to 1. And 1 over 4 is not greater than 1. So this condition is false. And because the one of two conditions is false, we reject this solution. This is not a solution. So finally we get two valid solutions. X is equal to negative 1 and x is equal to 1 plus square root of 5 over 2.